The disk formula. One of the most common methods of finding the volume of solid bodies is by rotating an area about some axis of revolution. One of the easier methods for getting the cross-sectional area is to cut the object perpendicular to the axis of rotation. Doing this, the cross-section will be either a solid disk if the object is solid, or a ring if we have hollowed out a portion of the solid. Let's look. On the left-hand drawing, we have a curve, and the intent is to rotate it about the x-axis. To the right is a depiction of the solid after the rotation. Notice that the cross-section is a circular disk. The formula for the volume, that is V equals the integral from a to b of a of x dx, where a of x is the formula of the area. If the area is a circle, then a is equal to pi times the quantity f of x squared. Then we get that the volume is the integral from a to b of pi times the quantity f of x squared dx. That distance is the radius, and that is the distance from the axis of rotation to the function. Example: determine the volume of the solid obtained by rotating the region about the x-axis bound by y equals x squared minus 4x plus 5 on the closed interval from 1 to 4. When reasonable, get a sketch of the graph. So we do have the sketch of the graph, y equals x squared minus 4x plus 5 on the interval from 1 to 4. It's the upward facing parabola. Now we're going to rotate it about the x-axis. That is, just flip it over. So our formula for the volume on the interval from 1 to 4 will be the integral from 1 to 4 of a of x dx. Let's sketch a few cross sections. They all turn out to be solid disks. The area is a circle whose radius is the distance from the x-axis to the function. So let's build on that volume formula, and we'll get the integral from 1 to 4 of pi times radius squared dx. That distance is our function, so the formula becomes the integral from 1 to 4 of pi times the quantity x squared minus 4x plus 5 squared dx. Let's perform the integration. We need to square that quadratic. So we'll have that the volume is equal to the integral from 1 to 4 of pi times, and then the quantity x squared minus 4x plus 5 times the quantity x squared minus 4x plus 5 dx. Multiply that out and simplify. When we rewrite, we'll pull the pi out to the left of the integral. So we'll have pi times the integral from 1 to 4 of x to the 4th minus 8x cubed plus 26x squared minus 40x plus 25 dx. Be sure to multiply out that squared quadratic on your own. Now let's integrate. We'll have pi times the integral of x to the 4th. We raise the power by 1, so it'll be x to the 5, 1/5. We divide by the 5. Minus, where we had 8x cubed, that becomes a power of 4. So 8 divided by 4 gives us 2x to the 4th. Plus 26x squared. The integral of x squared is 1/3 x cubed. So 26x squared becomes 26 over 3 x cubed minus the integral of 40x. That x becomes x squared. We divide by 2. So that integral becomes minus 20x squared plus the integral of 25 is 25x, and we evaluate that from 1 to 4. That means we evaluate the integral and put in 4 every place there's an x. That'll be pi times the quantity 1/5 4 to the 5th minus 2 4 to the 4th plus 26/3 4 cubed minus 20 times 4 squared plus 25 times 4, and we subtract that integral evaluated at 1. That would be minus, and then in parentheses, 1/5 1 to the 5th minus 2 times 1 to the 4th plus 26/3 1 cubed minus 20 times 1 squared plus 25 times 1. This solves to 78 pi over 5.